These are the most expensive single buildings ever constructed by human beings. Not skyscrapers, not stadiums, not airports. Semiconductor fabrication plants. TSMC's Arizona complex is projected to cost $165 billion. Intel's Ohio facility, $28 billion. Samsung's Texas mega-fab, north of $37 billion. Each one of these structures contains rooms cleaner than an operating theater, machines that cost $350 million apiece, and systems so precise they manipulate matter at the atomic level. And right now, over $500 billion worth of these buildings are under construction around the globe. This isn't a coincidence. This is a race between nations spending tens of billions of dollars each on a single type of building. A building most people have never heard of, in an industry most people couldn't explain, producing a product smaller than a human hair that controls virtually every piece of technology on the planet. But here's the thing that makes this unlike any construction boom we've ever covered. These aren't being built because someone wants to set a record or impress tourists. These are being built because every major government on Earth has suddenly realized the same terrifying truth. Whoever controls the chips controls the future. And right now, that control sits on a single island in the Pacific, an island that could be blockaded, invaded, or devastated by earthquake at any moment. This is why every country is racing to build the same $50 billion mega project. Okay, so to understand why nations are pouring the GDP of small countries into single buildings, you need to understand what a semiconductor fab actually is. And in all honesty, these things are mind-bending. A modern chip fabrication plant, a fab, is a factory where silicon wafers are transformed into microchips through hundreds of sequential steps involving extreme ultraviolet light, chemical vapor deposition, and etching processes that carve features just 2 nanometers wide. For context, a human red blood cell is roughly 7,000 nanometers across. We're talking about structures so small, they operate at the boundary of quantum physics. Now, to achieve that level of precision, the environment has to be impossibly controlled. The clean rooms inside these fabs are rated ISO Class 1, meaning there are fewer than 10 particles per cubic meter of air. A typical hospital operating room has roughly 35,000 particles in the same volume. The temperature has to be stable to within a fraction of a degree. Vibrations from a truck passing on a nearby road can ruin an entire batch of wafers. Even the molecular composition of the air has to be monitored. Building a structure capable of maintaining those conditions across hundreds of thousands of square meters is an engineering challenge on par with anything we've ever covered on this channel. But the construction challenge is only part of the story. The equipment inside these fabs is extraordinarily expensive. A single EUV lithography machine, built exclusively by the Dutch company ASML, costs around $350 million. Each fab needs multiple units. Then there's the power. A modern semiconductor fab consumes roughly 100 megawatts of electricity. That's enough to power a small city. It requires millions of gallons of ultra-pure water daily, and the total construction timeline from groundbreaking to first chip? 4 to 5 years minimum. So when we talk about a $40 billion fab, we're not exaggerating. This is a new category of megaproject entirely. You see, for decades, none of this was a crisis. The world was perfectly content to let semiconductor manufacturing concentrate in East Asia. And for good reason. The companies there were simply the best at it. Taiwan Semiconductor Manufacturing Company, TSMC, produces over 90% of the world's most advanced chips. Samsung in South Korea handles much of the rest. These two countries, both smaller than many US states, became the beating heart of the global technology supply chain. Imagine for a second that 90% of the world's oil came from a single refinery. You'd probably want a backup plan. That's exactly the position the world found itself in when COVID-19 hit in 2020 and suddenly the chips stopped flowing. Car factories shut down. Consumer electronics vanished from shelves. Medical device production slowed. A shortage of components smaller than a fingernail brought trillion-dollar industries to their knees. And then came the geopolitical wake-up call. Rising tensions in the Taiwan Strait made governments acutely aware of what a military conflict could mean. If TSMC's facilities in Taiwan were disrupted, whether by blockade, invasion, or natural disaster, the global economy wouldn't just stumble, it would collapse. Can you blame them for panicking? That panic crystallized in the United States with the CHIPS and Science Act, signed into law in August 2022. It authorized $280 billion in funding, including $52.7 billion specifically for semiconductor manufacturing and research. The message was clear. America was going to build its own fabs, whatever the cost. And the projects that followed are staggering in their ambition. TSMC's Arizona complex in Phoenix is the headline act. Originally announced as a $40 billion investment, the scope has since ballooned. TSMC now plans to build 6 semiconductor fabs at the site, alongside advanced packaging lines and a dedicated R&D center. The total investment is projected at $165 billion, making it one of the largest foreign direct investments in American manufacturing history. The U.S. government is backing the project with $6.6 billion in direct grants and $5 billion in loan guarantees under the CHIPS Act. Fab 1 began producing 4-nanometer chips in early 2025, churning out 10,000 wafers per month with plans to scale to 30,000. Phase 2 tool installations are scheduled to begin in 2026, with production starting in the second half of 2027. Apple has already committed to purchasing 100 million chips from the Arizona facility in 2026, a powerful signal that the reshoring strategy has genuine commercial momentum. Then there's Intel's Ohio complex, dubbed the Silicon Heartland. Originally costed at $20 billion for 2 fabs on a 1,000-acre site near Columbus, the budget has swelled to $28 billion. Construction by Bechtel has employed up to 7,000 workers at its peak, with the finished facility expected to support 3,000 direct jobs and around 10,000 indirect positions, at an average salary of $135,000. But Intel's project hasn't been plain sailing. Production start has been pushed back repeatedly and is now expected between 2030 and 2031. A $95 million 500-megawatt power substation built specifically for the fab sits idle, capable of powering 500,000 homes, but currently serving no one. And Samsung's Taylor, Texas facility tells a similar story of ambition meeting reality. Originally announced at $17 billion in late 2021, total investment in the region has expanded to $44 billion, including additional fab modules, R&D, and packaging. The plant is reportedly 91.8% structurally complete. But here's the catch. Installation of key chip-making equipment has been delayed due to a lack of confirmed customers and shifting technology demands. Samsung has struggled with yields on its cutting-edge 2-nanometer process. Early production yields reportedly sat between 10 and 20%, eventually climbing to 50 to 70%, closer to, but still trailing TSMC's 65 to 80%. That gap in performance has made potential customers hesitant to commit. Samsung has also had to invest heavily in utility infrastructure to supply adequate power, exposing limitations in the Texas grid that few anticipated when the project was announced. Now, from building the world's most precise factories to keeping track of their colossal budgets, managing a project this complex would bring most of us out in a cold sweat. Because here's something that doesn't get nearly enough attention: the sheer difficulty of building these facilities in America. TSMC's own CEO has noted that construction costs in the United States are around 1.5 to 2 times higher than in Taiwan. Labor is more expensive. Permitting is slower. U.S. Treasury Secretary Scott Bessent himself singled out local building inspectors and regulatory red tape as key obstacles slowing fab construction. It goes deeper than bureaucracy. The specialized workforce simply doesn't exist at scale in the US. TSMC has resorted to flying American hires to Taiwan for 12 to 18-month training programs just to build baseline competency. These aren't assembly line workers. These are technicians who need to operate in environments where a single misplaced particle can destroy an entire production run. And there's the resource equation. Each fab demands enormous quantities of ultra-pure water. In arid Arizona, that's a serious long-term concern. The energy requirements are equally daunting. We're talking about facilities that need dedicated power stations just to function. Despite all of these investments, TSMC's Arizona complex may only satisfy around 7% of total US chip demand. 7% for $165 billion. But this race extends far beyond America's borders. The CHIPS Act has catalyzed investment across 28 US states. More than $630 billion poured into over 140 projects, creating an estimated 500,000 jobs as of late 2025. Yet globally, the competition is even fiercer. The European Union launched its own European CHIPS Act, targeting 43 billion euros in public and private investment. Japan is luring TSMC to build a facility in Kumamoto. South Korea has unveiled a $471 billion plan to create the world's largest semiconductor cluster. Even India, with no history of advanced chip manufacturing, is building fabs with Tata Group and international partners. Every major economy has looked at the same map and drawn the same conclusion. Dependence on a handful of fabs in East Asia is an existential vulnerability. TSMC itself is spending accordingly. The company projects capital expenditures of $52 to $56 billion in 2026 alone, with 70% dedicated to advanced logic fabs. Their revenues hit $122.4 billion in 2025, with 58% coming from AI and high-performance computing chip sales. But even TSMC's leadership is cautious. The company's CEO has publicly warned about the risk of an AI bubble driving reckless overinvestment in capacity. His words were stark. Careless investment would be a disaster for TSMC. Now, this all seems like a straightforward national security play. Build fabs at home, reduce dependency on Taiwan, secure the future. But the reality is more complicated than that. Intel's repeated delays, despite billions in subsidies and completed infrastructure, raise serious questions about whether money alone can manufacture competitiveness. Samsung's customer acquisition struggles and yield problems underscore that physically building a fab is only half the battle. You also need to produce chips that companies actually want to buy. There are environmental concerns too. The water consumption of a single fab could sustain tens of thousands of households. The energy demands contribute meaningfully to regional grid strain. Communities near construction sites face years of disruption, and the economic benefits are heavily concentrated. Over 80% of U.S. megaproject construction starts are in the South and West, potentially widening regional inequalities rather than narrowing them. And then there's the overarching question nobody wants to address. What happens if the AI boom driving so much of this demand turns out to be a bubble? If the chips being manufactured in these $50 billion buildings don't find enough buyers, the write-downs would be catastrophic. So who's going to win this global semiconductor construction race? Well, the safe money would say TSMC. They have the technology leadership, the manufacturing expertise, and now they're replicating their operations across multiple continents. Their Arizona facility is already producing chips. Their Japanese fab is on track. They are, by virtually every measure, the most important company in the world that most people have never heard of. But this isn't really a race with a single winner. It's a redistribution, a deliberate, multi-hundred billion dollar effort by governments to scatter the world's most critical manufacturing capability across multiple geographies so that no single event can cripple global technology. These aren't just factories. These are strategic assets that nations believe will define economic and military power for the next century. And the construction teams building them are operating at the absolute frontier of what's physically possible, creating environments clean enough to manipulate individual atoms in structures large enough to see from space. Thanks for watching Hard Hat Industries, your source for the massive engineering and heavy iron shaping our world. If you appreciate the scale and technical complexity of these builds, hit like, subscribe, and turn on notifications so you never miss a breakthrough.